Okay, so, hold on. Okay, so before we get into this assignment, I want to give some definitions here, right? So today we'll be talking about, oh shoot, this is not plugged in. Okay, so today we're talking about acids. Let me make this. Okay, so today we'll be talking about, that seems a bit too broad. Acids and bases, all right? So let me define what an acid is first, right? So an acid is a substance that, when added to water, produces hydrogen ions, or H plus ions, all right? So any substance which does this, we call it an acid. So for example, if you add hydrogen chloride to water, oops, you're gonna get H plus and the chloride ion. So you're going to have a byproduct, but the important product here is the hydrogen ion that is produced. Here's another example. If you take nitric acid in water, will produce H plus ions and nitrate ions. All right? Or in the case of sulfuric acid, when added to water, will produce hydrogen ions and hydrogen sulfate ions. All right? So in all these cases, as you can see, they produce hydrogen ions when they're added to water.
Essentially just a proton, right?
Which is basically a proton, right? So actually, let me just write this down. So H plus ion is the same thing as a proton, right? Because basically it's a hydrogen atom with an electron stripped away from it. So all you're left with is a proton, right? So that's basically what an acid is. An acid is a substance which, when added to water, produces H plus ions. All right? Okay, let me see something here. So that's the definition. And by the way, the definition that we're dealing with here is called the Bronsted-Lowry definition. There's some other definitions as well, but we won't get into that right now. All right? So according to the Bronsted-Lowry definition, an acid is a substance which, when added to water, produces hydrogen ions. Now, on the other hand, I need some space here, so let me just oops, what did I do? You know what? Let me just create a new page. Okay, so now we're going to get into bases. What are bases? Bases, and again, this is according to Bronsted-Lowry, these are substances that, when added to water, produces hydroxide ions. All right? So an example would be sodium hydroxide. When it dissolves in water, it produces sodium ions and OH minus ions. And here's one example, which is kind of different from what we have here: ammonia. Now, ammonia by itself does not have any hydroxide ions present, but what happens when added to water produces, I'm sorry. What is going on?
I think you keep hitting the fill button by mistake or something.
Yeah. All right, sorry about that, folks. Okay, so as I was saying, sodium hydroxide produces sodium and hydroxide ions when added to water, right? Now, ammonia, I was about to say, is different because ammonia does not have any hydroxide as a part of its structure, but when added to water, a reaction takes place where the products would be NH4 plus OH minus. So even though there's no hydroxide here, when it reacts with the water, so you add it to the water, there's a reaction that takes place. And the products of that reaction would be the ammonium ion and the hydroxide ion. So for that reason, ammonia is considered to be a base because when added to water and dissolves, it produces the hydroxide ion, all right? So that's the difference between acids and bases. So an acid is a substance which, when added to water, produces hydrogen ions. A base is a substance which, when added to water, produces hydroxide ions. Now, there are some other terms that you need to be aware of. Erase this here. In fact, let me continue down here. I don't need to erase. Okay. So some other terms that you need to be aware of. One of them is conjugate base. And the other one is a conjugate acid. But let's deal with the conjugate base first. A conjugate base is what is formed when an acid loses a proton or hydrogen ion. All right? So for example, HCl, right? When that loses a proton, it forms this proton and a Cl minus, right? So this is called the acid, right? Because it produces hydrogen ions. And this is called the conjugate base of the acid. So it's called the conjugate base because the hydrogen ion, when removed, gives you this. And you notice that the chloride has a negative charge here, all right? So that's basically how you determine what the conjugate base is for an acid. The conjugate base is basically what is formed when a hydrogen ion or proton is removed from an acid, or for that matter, any compound that contains hydrogen. So I can point out some other examples. Let's say, for example, you're given, trying to think of a good one. H3O plus. All right. So this is called the hydronium ion. Okay. Now, the thing about the hydronium ion is that it can lose a hydrogen ion, right? So when this loses the H plus, what remains will be H2O, right? So this here would be the acid in this particular situation, and this here would be the conjugate base of the acid, all right? Now, one thing I want to point out here is that in the case of this particular ion, there's a plus charge here. But when the H plus is removed, then what is formed will be a neutral molecule. There'll be no charges, right? Now, that is kind of different from what is happening in the first case I gave you, HCl, which is neutral. And then when you remove the H plus, you end up with a negative charge here on the chloride ion, all right? So basically, what you should notice in both cases, however, is that as you go from the acid to the conjugate base and losing a proton, the charge is reduced by 1. So therefore, in this case here, the charge of the molecule is 0, it's reduced to -1 to get the conjugate base, right? The charge here would be +1, but it's reduced to 0 in the case of the conjugate base here, all right? And that's because in each case, you're losing a plus charge with the hydrogen ion, all right? So that's basically what happens in this case. So, okay, so that's a conjugate acid. Now the conjugate base is basically the reverse of that. Let me just, so in the case of a conjugate base is what is formed I'm sorry, that was a conjugate base. I thought I'm confusing it. We're going to talk about conjugate acid now. I'm sorry. So this should be conjugate acid, not base. So in the case of a conjugate acid, this is what is formed when a molecule gains an H plus ion or a proton, all right? So for example, if I were to give you, let's say, H2O plus H plus to give H3O plus, then this would be acting as a base, so to speak. But this now would be the conjugate acid of this base here. Now, the reason why I call this a base is because it's reacting with H plus, right, which is an acid, all right? So basically, what you'll find is that the charge increases as you go from the base to the conjugate acid. Let me give another example. Let's say you're given HSO4 minus, and you add H plus to get H2SO4. Then this here is considered to be the base, and this is considered to be the conjugate acid of the base, all right? So that's basically how that works. All right, so now that we have covered the definition, let me talk about what we call the neutralization reaction, which is the reaction between an acid and a base. So let me get onto this here. So let me talk about neutralization reaction. And that's a reaction between an acid and a base. To form a salt and water, right? So, for example, hydrochloric acid is, of course, an acid, and sodium hydroxide is a base. So what's going to happen is, and this is what happens in neutralization reactions, the hydrogen from the acid will come together with the hydroxide from the base to form water, right? And then whatever is remaining will come together to form the salt. So in the case of NaCl, that's the salt that is formed from the reaction between the sodium hydroxide and the hydrochloric acid. All right? So that's basically what happens in a neutralization reaction. The reason why they call this a neutralization reaction is because the acid is acidic, the base is basic, and the product is supposed to be neutral. In other words, the product is neither acidic or basic. All right, that's basically what happens in a neutralization reaction. All right, okay. Okay, so what should I talk about next? So,
Not one of the words on the paper, is it?
Neutralization.
I'm sorry, excuse me, neutralization reaction. It's not on this paper, is it?
not on this that I have here, which I'm going to give you guys shortly.
Okay.
Okay. Now let's say you're given an acid. I'm just going to give just one example here. Let's say you're given this acid, H3PO3, right? So this is your acid. So my question to you is, how would you determine the conjugate base? So if you remember what I said earlier, the conjugate base is what is formed when the acid loses a hydrogen ion. So if this loses, oops, I keep touching the wrong thing. If this loses an H plus ion, minus H plus, then what would be the resulting structure? Or what would be the resulting formula? That's what I should say. What would be the resulting formula? If H3PO3 loses a hydrogen ion, then what would you expect the formula for the resulting compound is?
H2,
H2,
PO3,
PO3,
U plus,
nope,
no,
you're losing a plus charge from something neutral. So what do you think is going to happen here?
negative charge.
Exactly. So that would be the formula for the conjugate base of the acid that is given, all right? Let's say I gave you NH2 minus, and I ask you, so this is going to be your base, right? And I ask you to determine what the conjugate acid is. Now, to get the conjugate acid from the base, we add an H plus, right? So if you add an H plus to this, then what would be the resulting formula?
NH3.
NH3, exactly, and that's it. All right? So basically, that's how you determine the conjugate base based on the acid, and also to determine the conjugate acid based on a base. Okay, let me give you two more examples, and then we can look at the assignment questions. Let me clear this here. Oh, now I should be able to just learning. Okay. Okay, so let's say I gave you I'm trying to think of a good example. Okay, let's look at this reaction here. Suppose I gave you okay, here's one. Now, in this case here, what's happening is that the ammonium, right, is giving up its hydrogen ion to the water to form the hydronium ion, and ammonia will be formed as well, because when this loses the hydrogen ion, you end up with this, right? So basically, we can identify, for example, this is acting as an acid, right? So basically, when it loses a hydrogen ion, minus H plus, you're going to end up with this. So if this is an acid, that means this will be the conjugate base. I'm just going to use CB to abbreviate for conjugate base, right? And on the other hand, in this case here, we have the water gaining a hydrogen ion to form this. So water here is acting as a base, and the hydronium ion would be the conjugate acid of that base, all right? So this is an acid-base reaction, believe it or not. In this case, the acid, let me write this down. In this type of reaction, the acid will lose protons or H plus ions, while the base will gain protons, right? So this is another alternative definition definition for acids and bases based on the reaction that is taking place, right? So in this reaction here, it's an acid-base reaction because one substance is losing hydrogen ions and the other substance is gaining hydrogen ions, all right? And once you determine what the products are, then you can identify what is an acid and what is a base, and what would be the conjugate acid of the base, and what would be the conjugate base of the acid, all right? So, maybe I should finish this sentence here. The acid loses a hydrogen ion to form a conjugate base, and the base gains hydrogen ions to form a conjugate acid. All right, so that's basically how that works. And there's a term that we use in chemistry when it comes to these types of reactions. We say that NH4 plus, for example, and NH3, that is called a conjugate acid base pair. Conjugate acid base pair. Base pair. And for the H2O to H3O plus, we also call that a conjugate acid base pair. All right. So that's basically how all those definitions come into play when it comes to an acid-base reaction. All right. Okay, any questions about this? Any questions? Any questions? Okay, so let's say I gave you this. Let me get rid of all of this here. Let's say I gave you HSO4 minus plus H2O to form H3O plus. No, let me not use that. Sorry. Let me erase this here. Let me use something else. Instead of that, let me use Cl minus to form SO4 2 minus plus HCl. All right, this is a good one. All right, so based on the example that I gave you earlier, you can feel free to look at that to help you with this. I want you to tell me on this side, which of the two on the left side is an acid and which is the base. Feel free to look at the example I gave you earlier. So which do you think is the acid and which do you think is the base?
The HSO negative and the SO4 -2 is a acid.
Well, we're not talking about what's on the right side.
Oh, only on the left side.
But you're right about HSO4 is the acid. Okay, very good. Which means that the chloride is the base. Okay, very good. So that takes care of the left side. So on the right side now, one of them is a conjugate acid and one of them is a conjugate base, right? So which is which? Let's start out with the conjugate base. Which is the conjugate base? Now remember, the conjugate base is what happens or what forms when the acid loses a proton. So which of the two on the right would be the conjugate base?
SO4 -2.
Exactly. So this would be the conjugate base. I'm just going to put CB here, which means that this would be the conjugate acid, right? Okay, very good. So that's basically how you can determine what is what in terms of acid base, conjugate acid. So let me just say that this pair here, that's a conjugate acid base pair. Conjugate acid base pair. Right? And the other conjugate acid base pair is right here between the chloride and the hydrochloric acid. So this is another conjugate acid base pair. All right. So that's how that is done. All right. So let me start off by giving you this worksheet. Did we finish the last one?
I wasn't here.
Oh, you weren't here either? Okay, I'm getting those, so I don't remember. But we can at least start this one. This is basically an extension of, oh shoot, I forgot to. Oh, wait a minute. That's the original, sorry. This is what I should do. Let me give you this copy here. Okay, so basically, let me see if I can bring this up on the screen. So let me see. Where is it? Is it this? Yes, okay. So, okay, so the first question we should all be able to answer it. So let's hear what you have to say. The question is asking, according to the Bronsted-Lowry definition, what's an acid?
A substance that loses.
Okay. A substance that when added to water will form or produces hydrogen ions. All right. And you can probably, well, not probably, you should add to that definition, you should add also a substance which would give up a hydrogen ions to a base, or would give up hydrogen ions to a base. A substance that will give up hydrogen ions to a base. All right. And then, so that's 1A, and 1B is what? What is a base?
It will gain water.
No, it will gain. When a base is added to water, what is produced?
This is.
Look at the definition I gave you earlier. When a base is added to water, it produces what?
Produces OH.
Hydroxide ions, right? And I would add to that as well. So write that down, but add to that, a base will also add, a base will accept hydrogen ions from an acid. A base will accept hydrogen ions from an acid. Right? So that's the definition of an acid and a base. Now, the next question is asking, what is the conjugate acid? And again, feel free to look in your notes to answer that question.
It's formed when a molecule gains H plus.
Exactly. A conjugate acid is what is formed when a molecule, and I should say molecule or ion, so include that too. What is formed when a molecule or ion gains hydrogen ions. All right? And then D, what's a conjugate base?
That is formed when a acid loses H plus ion.
Exactly. And that's basically it for number one. So number two now is asking for you to give the conjugate base for each of these acids. So they gave you the formulas here, and you're to write down here what is the formula for the conjugate base. Now remember, the conjugate base is formed when an acid loses an H plus ion, right? So tell me what would be the answer for number 2A. Let's start off with that. Let me turn on my pen thingy here. Okay, so what's the answer for A? When HI loses a hydrogen ion, what is formed? When this loses a hydrogen ion, what would be the resulting structure, or I should say formula?
HI negative?
Nope. It's going to lose H plus. It's losing a hydrogen ion. So when this loses a hydrogen ion, what will be formed?
Hydronium.
Yeah, but we're talking about when it departs. So yes, you're right. It's going to form a, well, if water is present, yes. But what I'm asking is when the H plus leaves or is taken away from the HI, what will be the resulting formula?
Iodine minus.
I minus, exactly. All right. So that's the answer for A. What about B? If you lose a H plus from here, what will be the resulting formula?
NH3.
NH3. All right. What about C? If you lose H plus from this, what will be the resulting formula?
HCO3 minus.
HCO3 minus is correct. What about HNO3? If you lose H plus from that, you're gonna end up with
NO3 minus.
NO3 minus. Okay, very good. All right. So that's basically the answers for those. All right. Any questions about this? Any questions? Any questions? Okay. So in number 3, it's the reverse or opposite or whatever term you want to use. Let me clear this first. Let's scroll down. Okay, so this is the reverse or opposite of what you just did, because in this case, you're given a conjugate base and you're asked to determine the acid, right? Or the formula for the acid. So basically it's the opposite. You're adding H plus to each of these, and the question is, what's the resulting formula? So in the case of the first one, Cn minus, if you add H plus to this, what would be the formula resulting?
HCN,
HCN.
hydrogen cyanide.
Hydrogen cyanides. Yeah, you won't want to be in a room filled with this unless you're contemplating suicide or something. What about B? O2 minus. If you add H plus to this, then what would you get?
O2.
Think about it. You're adding H plus. So you're adding something with a plus charge to something with a -2 charge. So what's +1 -2?
It's gonna make water.
What's that?
Gonna make water.
No. You're just adding one H plus. Right? So if you add one H plus to this, then what's the resulting formula?
It's gonna be a hydroxide ion.
Exactly, hydroxide, HO minus. Exactly. All right. What about this? CH3COO minus. If you add H plus to this, then what will be the resulting formula?
COO8.
Right. Well, CH3COOH, or if you did this, I would accept it as well as the correct answer.
What chemical is that?
This is acetic acid. And acetic acid is what you'll find in your vinegar. So when you go to the store and you buy your vinegar to make, whatever, salads, whatever, it's basically an aqueous solution, a 5% aqueous solution of acetic acid, all right? They add some other things to it, but that's basically what it is. And also so that's 5%. There's also available commercially 30% vinegar, which is not made for human consumption. It's used for industrial purposes like cleaning stuff and all that. All right. Okay. Let me clear this and scroll down. Okay, last one in the series. NH3. So what would be the formula resulting when you add hydrogen ions to this to form the conjugate acid? What's the resulting formula?
H and H3?
Or you could just put NH4,
Okay.
but you're adding H plus, so there's something missing, a charge. So what's the charge?
Plus.
Exactly. And that's it. All right. Okay, so that's number 2. Let me clear this. And let's move on to number 3. Now, number 3 is asking for you to label the acid, the base, the conjugate acid, and conjugate base in each of the following reactions. So at A for acid, B for base, Ca for conjugate acid, Cb for conjugate base, right? Let's start off with A. So you have to look at, okay, answer this question. You have to look at the transformation of each of the substances involved as you go from reactants to products. In other words, you have to identify which substance is losing hydrogen ions and which substance is gaining hydrogen ions. The substance that's losing hydrogen ions, that would be the acid. The substance that gains hydrogen ions would be the base, all right? All right, so for A, which of the 2 reactants would be the acid in this case? So which of these two here and here should I put an A underneath?
H2SO4.
Correct. So put an A here, which means that the base would be ammonia, right? So on the other side, what's the conjugate base of the acid that's on the left? What's the conjugate base of the acid?
HSO4.
Exactly, HSO4 minus. So that's a conjugate base, which means that this would be the conjugate acid. All right? So that's the answer for A. What about B? Which of these two on the left side would be the acid?
HC2H3O2.
Yeah, exactly. So this would be the acid, which means that water would be the base. So let's look at the right side now. Of the two on the right side, which would be the conjugate base of the acid that's on the left?
C2H3O2.
Exactly. So this would be the conjugate base, which means that by default, we can say that this would be the conjugate acid. All right. Okay, the last one in this series, HCO3 minus plus HCl to give you Cl minus and H2CO3. Which of the two on the left side would be the acid? Which of the two on the left side would be the acid in this case? Ah. Here you go.
It's gonna be HCl.
Yep, correct. So this is HCl, that's the acid, which means that this is the base, right? So of the two on the right side, which would be the conjugate base of the acid?
Conjugate base is gonna be Cl minus.
Okay. Which means that the conjugate acid would be Ca. All right. Okay. So much for that. So let me talk about something else, and then we can probably look at some more questions. Whoops, let me clear this first. Scroll down. I just want to check out something here. I'm trying to remember, did I introduce molarity to you guys?
No.
Okay. I'm wondering if I should. Hold on 1 minute. Let me. Yes, okay, that's my fault. I should have talked about this first before. Okay, we can do, all right, tell you what, hold on, let me check something out here. Let me check out, no, not that. Let me go here. Okay, I don't know what that means. Okay. Okay, I should have brought this with me today. I guess I'll bring it next class. Let me just publish it so that you may want to look at it. This one here, I should have brought with me today. Let me just check it out here. Okay, yeah, I should have brought this with me today. All right, what I'm going to do is talk about solutions. And then, next time, I'm going to stop at where we stopped at in this assignment here. Next time, I'm going to bring this page here or this handout. But let me just talk about, solutions and different ways of measuring the concentration of a solution. So let me, go back to here and let me do the lasso of this, get rid of all this here. All right. So let's talk about solutions, and then next class we'll get into some problems involving solutions. So when we talk about a solution in chemistry, we're talking about a homogeneous mixture of two or more substances. All right. And we can have different types of solutions, right? So for example, you can have two liquids dissolved in each other, right? For example, you can have, let's say, let me give an example here. Ethanol, whoops. Ethanol and water, right? So if you're a person who like to drink alcoholic beverages like, wine, whatever, it's basically an aqueous solution of ethanol. Ethanol dissolved in water. Of course, other things are added, to give flavor to the substance, but that's basically what you're drinking, right? And that's a homogeneous mixture. In other words, when you add the ethanol to water and you mix it, with your own eyesight, you cannot detect the difference between the two because it's in one state or one phase, all right? Now, that is different from something like oil and water, right? If you add oil to water, we all know, for example, if you add cooking oil to water, then, and even if you stir it vigorously, if you leave it to settle, eventually it's going to separate into two layers, right? You're going to have the oil at the top and the water below, right? And there's a boundary between them. That would not be a solution, right? A solution must be, as stated here, a homogeneous mixture, right? In other words, its concentration or the ratio between the two substances would be the same throughout. So in this case, you have a liquid dissolved in a liquid, right? But you can also have, believe it or not, a solid dissolved in a liquid. For example, if you take salt and add to water and you stir it and it dissolves, then you end up with a solution as well, right? That would be a solid dissolved in a liquid, right? You can also have a gas dissolved in a liquid, right? For example, CO2 and water, right? So if you like to drink carbonated beverages, right? Like Pepsi and Sprite and all that, all those sodas. Basically, again, it's a solution where carbon dioxide is dissolved in water, right? Again, you'd add flavoring and all that good stuff, but again, it's a solution of carbon dioxide in water. And in this case, you're talking about a gas, which is carbon dioxide dissolved in a liquid, all right? Okay, so that's another example of a solution. You can also have a solution where you have two solids mixing. So, for example, steel, which is a combination of iron plus carbon. So let me just put there steel, right? So that is also a solution. That's a solution of a solid dissolved in a solid, all right? So those are just examples of solutions. In all cases, what they have in common is that you have two solids or two substances mixed together and it's completely homogeneous. Let me give one more example. One our very lives depend on. The air we breathe. That's a mixture of several gases, right? So air consists of carbon dioxide, oxygen, nitrogen, and then you have some other gases in small amounts, like argon and so on, etc. That is also considered to be a solution because that's also a homogeneous mixture, right? So what they all have in common, all of these here that we just discussed, what they all have in common is that it's a homogeneous mixture of two or more substances, right? And therefore we call that a solution, all right? Okay, so with that said, let's talk about how to express what we call the concentration of solutions, all right? And there are several ways of doing that, and it really depends on, your purpose for determining the concentration. So the first one I'm going to mention is parts per 100, or otherwise known as percent. Okay, so percent mass over mass, right? That is equal to the mass. Oh, by the way, before you even get to that, I should have, oh, could I forget this? There's one definition or two definitions that I need to talk about before we get into this. Again, in regards to solution, one of them is solute, and the other one is solvent, right? Because basically any solution that you have can be described can be described as having two parts. One of them would be the solvent, and the other one would be the solute. Now, typically, the solvent is the component that is in greater amount. All right? While the solute is the component that is in lesser amount. All right? So that's the solute and solvent, and together they make the solution, right? Now, so for example, let's say I gave you to mix 5 milliliters of ethanol plus 50 mils of water, right? Now, because the ethanol is in small amount, that would be the solute, while the water, which is in greater amount, would be the solvent, all right? So if you have two substances that are in the same phase, two liquids or two solids or two gases, the one in greater amount would be the solvent, the one that would be in lesser amount would be the solute. Now, what if you have like a solid dissolved in a liquid, right? Then basically, let me continue down here. If a solid is dissolved in a liquid, then the solid is the solute and the liquid is the solvent. All right, so for example, if I add salt to water and the salt dissolves, then in that particular solution, the salt would be the solute and the water would be the solvent. All right, and the same is true if you're dissolving a gas in a liquid. Again, the gas would be the solute and the liquid would be the solvent. So in the case of carbonated beverages, the carbon dioxide would be the solute and the water would be the solvent, all right? So that's basically it as far as making a distinction between the solute and the solvent is concerned. And that is important for us to discuss solutions. So let me get rid of this here. Okay, so as I was saying earlier, there are several ways to calculate or express the concentration of a solution. So the first one is what we call percent mass by mass. And that is equal to the mass of the solute divided by the mass of the solution times 100%. All right, so that's one way of expressing the concentration of a solution. It's the mass of the solute divided by the mass of the solution. And it doesn't matter what the units of mass is, as long as they're the same for both the solute and the solution, right? So it could be in grams, or it could be in kilograms, or it could be in pounds. It doesn't matter, right? So that's how we determine the percent by mass, right? There's another way of expressing the concentration, and that is parts per million, right? Put this in parentheses, parts per million, right? And that is equal to mass of solute divided by the mass of solution times a million, which is 10 to the 6, all right? So it's basically the same equation as in the case of percent mass over mass, but the difference is instead of multiplying by 100, you're multiplying by a million. And then there's another one, which is known as parts per billion, which is the same thing, mass of solute divided by mass of solution times 10 to the 9, which is 1 billion, right? So that's basically how we calculate these different ways of expressing the concentration, right? The last two, parts per million and parts per billion, those calculations or those ways of expressing the concentration is usually used by environmental scientists, especially when they're dealing with, for example, heavy metal concentrations in, aqueous environments like in rivers and so on. Those are usually very small amounts, and therefore the appropriate units for expressing the concentrations in those instances would be parts per million and parts per billion, all right? Now let me clear this and talk about some other ways of expressing concentration. There is also percent mass over volume, right? Now this one is a bit specific, more specific when it comes to units. That would be mass of solute in grams divided by the volume of solution in milliliters, in milliliters, all right? And then you multiply all of that by 100%, all right? So that's basically how we calculate percent mass over volume, right? Which is different from percent mass over mass, all right? And then there's another one, which is percent volume over volume, and that would be the volume of the solute divided by the volume of solution, and then we multiply all of that by 100%, all right? Now, in this case, the units of volume doesn't matter as long as they're the same for both the numerator and the denominator, right? So that's how we calculate that. So that's another way of expressing the concentration of a solution. So as you can see, in all these cases that we have looked at, to express the concentration of a solution, we take the amount of solute divided by the amount of solvent. Now, the amounts can be expressed in different ways, mass and volume, and later on we're going to see some other ways of expressing the units of the amount of solute and solvent or solution. All right? Okay. A couple more definitions, and then I think I'm going to call it a day. Let me just check something here. Okay, so in chemistry, I would say that the most common way of expressing concentration is what I'm about to show you, and that is molarity. So let me write this down. The definition of molarity is moles of solute divided by liters of solution. All right? So basically, in order for us to calculate the molarity of a substance, or I should say molarity of a solution, then you need these two things. You need the moles of the solute and the volume of the solution in liters. Now, the volume can be measured directly, right? We have glassware that we can use to measure the volume. But for the moles, you need to calculate that because you cannot determine that directly, right? So you'd have to do some calculation after getting the mass, right? And we all know how to convert from mass to moles, all right? In terms of the units of molarity, the unit of molarity can be based on this equation right here. So basically, the mole unit would be for moles, the liter unit would be for liters. So therefore, because you're dividing moles by liters to get this, then the unit of molarity would be moles per liter. And we can also express this as uppercase M, right? So in most textbooks, the units of molarity would be uppercase M, and you should understand that that means moles per liter. All right? So for example, let's say you have a solution where, for example, let's say we have a solution where we have 1.50 moles of 2.00 liters sodium chloride solution, all right? So if you're asked to find the molarity of this, then basically the molarity of this solution will be equal to the moles, which is 1.50 moles, divided by 2.00 liters. So whatever that gives, that gives 0.750 moles per liter, which is the same thing as 0.00750 M. And that would be how you calculate the molarity of a solution. All right? So that's basically how that is done. And this is the most common way of expressing the concentration of a solution, right? By dividing the moles of the solute by the volume of the solution in liters. Now there's one more that I'm going to give you, and I think I'm going to call it today after this. So, and this is not to be confused with molarity, right? So this one is called molality. Let me spell that for you. Molality. All right? And let me define that for you. It's the moles of solute in a solution divided by the kilograms of solvent in a solution, right? So that's molality, right? Molality is different from molarity, right? Molarity is moles of solute divided by liters of solution. Molality is the moles of solute divided by kilograms of solvent, all right? So the units of moles would be moles of the solute, and the unit of the mass of solvent is kilograms. So therefore, the molality unit is moles per kilograms. And again, in most chemical literature, this is symbolized by lowercase m, all right? So lowercase m, in this context, is the same thing as moles divided by kilograms in terms of the units, all right? Okay, so those are the different ways of expressing the concentration of solutions, different ways of expressing the concentration of solutions, all right? So I'm going to call today now because next class, I'm going to print the other handout so that we can deal with this first, and then we're gonna go back to this handout to deal with other topics such as pH and so on, all right? So we need to cover this first and understand how to do these calculations before we can do the rest of this assignment that we're looking at, all right? Okay, so unless there are any questions, that's pretty much it for today. So I'll see you guys next week. And let me remind you, because some students I had in the class before forgot or didn't know, tomorrow is a holiday, so don't come to college tomorrow. All right, there'll be no classes.
When is our break?
I'll have to look at the academic calendar for that. Let me see here. Thanksgiving will be November 26th to the 30th. November 26th to the 30th.
Okay.
That's a Wednesday up to Sunday.
Okay.
All right, so that's it for today, folks. I'll see you guys next week this time. What's up?
I didn't take the exam last week. Then we're gonna keep taking it here. Or. Possible.
Okay, yeah, but that'll be my office. I have to go for lunch first. So, but my office hours today is from 2 to 5. So if you can't come within that time, room 220I
220.
in building 2.
Building 2.
Yeah,
Okay.
all right?
So you said 2 to 5?
2 to 5, I'll be there. Yes, ma'am.
So I'm about to go take the test. I
Mhm.
asked to extend, everything should be at the testing
Yeah.
center, right?
And if you have any issues, call me as soon as possible,
Yes.
because sometimes
221.
220I,
Okay.
that's my office, yeah.